Alright folks, welcome back to geometry. Yay! We're going to wrap up the first unit or chapter on the basic tools of geometry, and we're going to do that with a little bit of midpoint and distance in the coordinate plane. So we're going to work with a couple of formulas here. I know that's your favorite thing to do ever, and we're going to take a look at some of the questions that might be asked and how we can work with the two formulas. So we want to talk about concepts with midpoint and distance, and one of the things I'll do is help you figure out what in the world that the textbook is telling you. So if we flip back in the textbook, we can talk about this key concept, midpoint formulas, okay? And we can talk about what's going on with midpoint and how the formulas work. So what is the midpoint? We already know that from previous stuff. It's a point right in the middle of a segment. Okay, so if you look at this example of a segment between A and B, the midpoint, well, is right in the middle. And they give you a little formula for that. If the value of point A is little a, and the value of point B is little b, then the midpoint is the average of the values. Okay, so that's going to be important. The average of the values, and that's a pretty significant note there, because that note is the same as the coordinate plane. Okay, so if you look at the coordinate plane note, this is kind of crazy. If you have a segment somewhere existing in space on the coordinate plane, and you have ordered pairs now. Okay, segment AB. Where the ordered pairs for segment A, remember how an ordered pair works? You get an x-coordinate and a y-coordinate. Okay, so you got to remember that stuff. So the x-coordinate and a y-coordinate, vocab. You have that for ordered pair A, and you have an x-coordinate and a y-coordinate for ordered pair B. That's what that means. To find the midpoint of that segment in space, take a look at this. So the formulas look kind of crazy, but the midpoint formula is the average x-coordinate and the average y-coordinate. Okay, so it's the average x-coordinate, add them, divide by 2, and the average y-coordinate, add them, divide by 2. So notice what's happening with the two things. We're adding things and dividing by 2, because with two entries, that's how you find the average. You add them and divide by 2. Okay, so the textbook goes through a couple things. I just wanted to show you that so you can decipher it, and then we can run through some midpoint examples with the page I was showing you. Okay, so when we go back to where I was, of course, which was here, and we could look at numbers 33 and 34. I'm going to skip around here. We're going to hit those midpoints first. Okay, so we're going to look at number 33 and 34. Now we read what's going on. Okay, it's going to be an important thing. So read that. Segment AB has endpoints. A is at -3, 2, and B is at 3, -2. And so what we're going to do is find the coordinates of the midpoint of segment AB. And then we can look here on the other side, how do you find the midpoint? And you can totally read this formula, as a robot. x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. You can totally read it that way. But man, I'm telling you, life is easier if you understand simple things. And so if you're going to look for the midpoint for 33, think midpoint is the average x and the average y. That makes life a whole lot easier. And so how do we find the average x? Well, you add the 2 and divide by 2. So in this particular example, we have x-coordinates at -3 and 3. So the average x is -3 plus 3, and then divide that by 2. That's the average x. Those two values, and divide by 2. So that's your average x. And then you're going to take your average y. Okay, so the y-coordinate is 2 here, and this y-coordinate is -2. So we're going to find the average y. So remember we had 2 there, and then we're going to add that to -2, and that will be our average y when we divide that by 2. Okay, so we simply divide that by 2. Now this particular question becomes kind of easy because you'll see something cool happen. Negative 3 plus 3 is 0, and 2 plus negative 2 is also 0. And so we have 0 divided by 2, which of course is 0, and 0 divided by 2, which is 0. So the midpoint, in number 33, the midpoint is at the origin. Okay, so hopefully you remember what the origin is. It's the very smack middle of the coordinate plane. So that's how the midpoint formula works. Okay, so in all the in the assignment, when we're looking at midpoint, that's what we're using. Now you can read it robotically. You totally can. But if you're thinking average x's and average y's, that's going to really help out a lot better. Okay, but now what we're going to do is take a look at 35, 36, and 37. There's some interesting things that are going on here. Okay, so first of all, we read the directions. M is the midpoint of segment JK. Find the coordinates of K. I don't even know what that means. I don't even know what this question is asking. M is the midpoint of JK. Find the coordinates of K. What? So we have a little skill that we can use here, and that skill is draw a picture. So with this thing that's going on, it's saying M is the midpoint of segment JK. What does that mean? Well, that means there exists a segment JK. That's totally what that means. So draw a picture, dudes, right? So midpoint of segment JK. Draw a picture of JK. That means the midpoint is right in the middle. And everything else is built off of that. Then the whole question is, find the coordinates of K. What? How? Well, in each problem, they give us some info. Okay, so the info is that the ordered pairs for J are negative 8 and 4, and the midpoint, the result of the average x's and average y's is this. So this gets a little bit tricky. We've got some equations in hand, right? So if we look for 35, okay, J is one of the segments. The midpoint is the result of the averages. Okay, M, the midpoint is the result of the averages. J is one of the endpoints. K is one of the endpoints. That means when we take the average x from J and K, we get this. We take the average x from J and K, we get, in this case, negative 1. We take the average y of J and K, we get 1. So, mathematically, what we're saying is that when we add the x-coordinate of J, negative 8, right? If we add the x-coordinate of J to the x-coordinate of K, which we don't know. We don't know the x-coordinate of K. Say, what? K happens to have an x-coordinate and a y-coordinate. We don't know what that is. That's what the question is asking. So finally, as you're trying to figure this out, now we understand the question. Find the coordinates of K, we have to find the x-coordinate and y-coordinate. We have to know what the question's asking. And sometimes that takes reading a whole lot of times, drawing a picture, understanding what you can understand of midpoint, to figure out what's happening, to figure out the question is sometimes the hardest thing, like in this example. So anyway, back to finding out what's going on. So we have the x-coordinate of J, which in number 35 is negative 8, and the x-coordinate of K, which we don't know, so we'll call it x, and we divide that by 2, we're going to get the x-coordinate of M. If we divide that by 2, we're going to get the x-coordinate of M, which is negative 1. Holy mackerel. We just made an equation. Mind blown. Bam! So we have to understand this is what's happening. Okay, so we found the x-coordinate of J, the x-coordinate K, we don't know. Divide that by 2, the average x, and we get the x-coordinate of M. Okay, so you see what's happening here. Now we can figure out what the x-coordinate of K is. So how does this work? We have to solve this equation for x. We have x's and 1's and a whole lot of things going on. So the first thing we can do with this particular deal is to clear the fraction. Now, how do you clear fractions? You multiply by the denominator. Okay, so how do you clear fractions? You multiply by the denominator. So in this case, we're going to multiply by 2. And if we multiply both sides by 2, what's going to happen is we see something kind of cool. So this entire left-hand side, we're going to multiply by 2. And then this entire right-hand side, we're going to multiply by 2. And then something cool happens. On the left-hand side, 2 in the numerator, 2 in the denominator, that is the number 1. 1. Check it out. 1 times all that stuff, which doesn't make any impact. So it clears the fraction, okay? So what we'll be left with is negative 8 plus x on the left-hand side. On the right-hand side, negative 1 times 2, negative 2. All we have to do now is undo that minus 8. How do you undo a minus 8? Well, you add 8, right? Yay, x is 6. So in this example number 35, we just found x to be 6. Okay, so we now have the x-coordinate for k. We now know the x-coordinate is 6. How do we find the y-coordinate? Well, we're going to do this exact same thing. So how do you find the y-coordinate? It's the same way. Remember what the midpoint is. The midpoint is the result of the averages. So with number 35, we have our endpoint j, the y-coordinate is 4. The endpoint k, the y-coordinate we don't know. The result of the midpoint is 1. So to find our average y, we have our y-coordinate for j. We have our y-coordinate for k, which is, we don't know. But we do know if that we divide that by 2, we're going to have the result of the y-coordinate of the midpoint of 1. Okay, so we have now created this other neat equation. And the process for solving this equation remains the same. The first thing we can do is clear the fraction by multiplying both sides by 2. So I'm going to move this one a little bit quicker because the process is the same as what we did over here. If we multiply both sides by 2, on the left-hand side, we'll be left simply with the numerator, 4 plus y. On the right-hand side, when we multiply by 2, we'll have 1 times 2, which is 2. And then to finally solve for y, we have to undo that 4. How do you undo a 4? Take it away. Okay, so we undo a 4 by taking it away. And we have left y equals negative 2. So we found the y-coordinate of k, right? That's what we've just done. Now we found the y-coordinate of k. It's negative 2. So, voila. Okay, we have found 6 and negative 2. All right? So that's how we would use that process. I'm not going to work out 36 and 37 because it's the same process. It's all the same stuff. But I do want to show you a shortcut if you're paying attention. Now, if you're paying attention, this is what's happening. Check this out. You got to listen carefully now. Listen up. Listen. So if you're playing your dang music, stop it. Listen now. Knowing what the midpoint is, you can figure this out without using math. Okay? If j has the end coordinate and m is the midpoint, how far is negative 8 from negative 1? It's 7 units. Now it's 7 units up, right? 7 units higher. So 7 units higher from negative 8 is negative 1. So that's the midpoint. If we go 7 units higher than that, we're going to end up at k, okay? So what is 7 units higher than negative 1? Positive 6. Whoa. Whoa. Same thing happens for the y-coordinate. J is the end point. M is the middle. How far is it from 4 to 1? It's 3 units. And it's 3 units down. 3 units down. So from the midpoint, what is 3 units down? Negative 2. Shortcut if you're paying attention. Shortcuts you'll find are for those that earn them and deserve them. So that is how we use the midpoint formulas for working with endpoints. Now let me skip back to the textbook because they show you this as well. Okay, this is in the textbook as well, but I'll teach you how to figure that out. Right. So all of that crazy old algebra is happening in the textbook. Okay, it's right here in problem 2, where it's talking about finding an endpoint. Okay, so this is exactly what we just did, but the textbook is there to help you. Okay, so this is what we've just done, as a matter of fact, and I'll show you how that shortcut works in a second. So here it sets up the equation. Use the midpoint formula to set up your equation. Multiply each side by 2. Simplify. You have now solved. Okay, but now let's use our shortcut. Take a look. Here's the midpoint, -2. Here's one of the endpoints, -5. How far is -5 from -2? 3 units. 3 units up. What's 3 units up from -2? +1. Here's the midpoint for the y-coordinate is 1. Midpoint, or the endpoint for the y-coordinate is 7. How far from 7 to 1? 6. 6 units down. What's 6 units down from +1? -5. Okay, so if you're paying attention, shortcuts are for you. All right, on to distance. Let's use the distance formula. The distance formula is based off of the Pythagorean theorem. Okay, the sum of the squares of any 2 legs of a right triangle is equal to the square of the hypotenuse. What, Mr. Katz? That formula. Okay, so to solve for the distance between any 2 points, we're using the hypotenuse of an invented right triangle. It's all based on the Pythagorean. Oh, there it is, right there in the textbook, based on the Pythagorean theorem. So you'll verify the distance formula in Chapter 8. So this comes back later. In the meantime, hey, look, there's this handy-dandy formula. And so we're going to use the distance formula real quick, and then we'll be done with this lesson. So I'm going to flip back to where we were, and I finally can go to the first exercises. So we have these 3 sets of ordered pairs, and we'll just work with, they all have negatives. Let's do number 31. Why not? Okay, so if we look at number 31, we can find the distance between those 2 points. How? With this distance formula right here. So the distance is equal to the square root of, okay, the square of the difference of the x's, subtract the x's, square it, and the square of the differences of the y's. Subtract the y's, square it. Okay? So it doesn't matter which is first y and the second y, or the first x and the second x, because you're subtracting and mathematically you're squaring. So there's some neat math that's going on here, but I'll make it quick for you. Okay? So with number 31, we're taking the square root of the square of the difference of the x's and the square of the difference of the y's. Okay, the square of the difference of the x's and the square of the difference of the y's. Okay, so if you can read formulas a little bit smoother, you might find life becomes easy. So the square root of the square of the difference of the x's. Okay, so what are the x's in number 31? -1 and 6. So to find the difference, we're going to subtract them. -1 minus 6. Okay, but it's the square of the difference of the x's. Okay, and we're going to add to that the square of the difference of the y's. Okay, so what is the difference of the y's? We have -1 and 2, so it's -1 minus 2. And it's the square of the difference of the y's. Okay, so if you can read the formulas better, it's all set. The square root of the square of the difference of the x's and the square of the difference of the y's. Okay? Okay. Now, just make sure, I'm going to recolor in these minus signs here because the minus signs is part of the formula. It's the difference. Okay, so it's always going to be minus, no matter what. Okay, so let's take a look. What's going to happen when we start crunching numbers? Now we crunch numbers. So what's happening here? -1 minus 6 is -7. Okay, So it's going to be negative 7 squared here. Negative 1 minus 2 is negative 3. So it'll be negative 3 squared here. All right, so that's what's happening there. And now we just do some squaring. Since we're squaring, that's why it won't matter positive or negative, because all squares are going to be positive, right? Except for imaginary numbers, but whatever. So negative 7 times negative 7 is positive 49. Negative 3 times negative 3 is positive 9. And so we end up with the square root of 49 plus 9, which is 58. Now we have to pause for a second because the instructions were to find the distance to the nearest tenth. The nearest tenth. The nearest tenth. Do you know your places? So let's use our handy dandy calculator. This is the calculator that we need to use in the state of Florida because Florida. Okay, since we're working in Florida, yay Florida, we have to use in geometry the TI-30XA, no other. So how does this work? How do you take the square root of 58? Well, quite simple. 5/8, square root of square root button. Yay. So now we have this crazy long number, and you have to know what the tenth is. Okay, the tenth is the first decimal place. So 7.615. 615 rounded is going to be 7.6. Okay, so we know it's going to be about, by the way, that's about. So it's going to be about 7.6 units. Okay, and that's going to be the distance between those 2 points. And that's the distance formula, and that's how we use it. And it won't matter, you'll see, it doesn't matter which order your x's and y's are in. You're going to get the same thing, okay? So that's midpoint and distance, and that's going to round out tools of geometry. It's going to round out tools of geometry, and we're done with that unit. So finally we can start getting into some really cool stuff later. I hope that helped. Practice, practice, practice. Peace out.